When we discussed the differential concept, we said that delta y equals f prime x delta x, not equal, actually approximately equal. So this fact can be used for the approximation using differential. Actually, that is implies dy equals f prime x dx, and we can use that idea as a for the approximation using differential concept. Using differentials, okay? So from these two facts, we can say that from here we can say that dy approximately equals delta y. So by using differential, this is differential actually, differential, we can approximate the change of the y, increment in y, okay? So interpret this result geometrically, we need to recall the basic properties of the slope. The vertical change in a line is equal to the produce of the slope, and the horizontal change as shown in the following graph. This is Cartesian coordinate system. So this is our line, okay? So what is the slope? Slope is if this length is b, this length is a, for this alpha also, which is alpha, tangent alpha, it is defined as a tangent alpha, but we can say that slope is, which is noted by m, slope is b over a. Okay. Now consider the line tangent to the graph of y equals f of x. So we have a line, we have a curve, sorry. This is our curve. So at this point, for example, let's consider the tangent line. This is our tangent line. So since f prime x is the slope of the tangent line for this point x, the slope of the tangent line is f prime x, okay? And dx is the horizontal change. If you look here, this is the horizontal change from this point to that point. A is dx horizontal change, b is dy vertical change, okay? So dx is the horizontal change, delta x actually x horizontal change, but we can consider dx. So for this point, let's look here. Okay, let's use this color. So for this change x, if this is delta x, also this is dx, okay? So this is x plus dx or delta x, let's note by delta x. This is exact change. This is increment in y. But when it is not easy to calculate the that value, this is the change. That's right. For example, easily you can calculate this value. There is no problem. So you can calculate this value as a f of x. So to calculate this value, if you can approximate the delta y by using differential, we can say that it's not exact value, of course, but exactly this value is dy. So instead of to find the f of x plus delta x exact value, we can find the approximate value of this point. This is f of x plus the dy, differential of dy, change of dy, okay? So by using differential, we can approximate this value when we cannot calculate that value. For example, let's write an example. we try to approximate the 4.01. I don't know what is this value, but I know square root of the x function graph. This is the square root of the x function graph. At the point 4, easily I can calculate this value, which is 2. Okay, y equals square root of the x function. My aim is to find the that value, 4.001. Okay, but I don't know what is this value. So by using this tangent line, approximately we can calculate these values easily, which are very close. Okay, so differential of the y equals f prime x times dx. What is fx? Fx is square root of the x. Maybe you don't know the square root of the x derivative, but as I remember, you have already learned. But let's write as a recall. Derivative of the square root of the x equals square root of the x is the x to the power 1 over 2. So 1 over 2 times x to the power 1 over 2 minus 1, which is 1 over 2 square root of the x. So f prime is 1 over square root of the x. So 1 over 2 square root of the x dx. So this point is, purple point is 4.01. Actually, our aim is to calculate the this value. So our aim is to find that value actually. So change of the x here, this is change of the x, which is dx 0.01. So at the point x equals 4, we can calculate the differential of the y. So this implies differential of the y equals 1 over 2 square root of the 4 times 0.01. So this says 0.01 over 4, which is 0.0025. So this value is differential of the y, not exact change of the y, but approximate change of the y. So onto this line, this is the approximate change. So exactly that value is 2 plus 0.0025. Okay, so this value 2.0025, but which is approximately equals to question mark f of 4.01. So as a result, f of 4.01 approximately equals, actually what is, which is actually exactly equals f of 4 plus delta y, exact increment of the y. But y approximately equals, delta y approximately equals differential of the y. So this approximately equals f of 4 plus differential y. So f of 4 is 2. So 2 plus 0.0025, which is 2.0025. Okay. So this is the square root of the 4.01. So actually, what is exact value of the 4.01 square root? Is that one, the exact value. Okay, let's write the exact value. The exact value by using calculator is 0.002498 4 blah blah blah. As you see, this is approximate value, this is exact value. So these are very close. So we use the differential to approximate the some values.